Welcome back. In lecture 34, we will continue with trip production and attraction, the second part. So, we will develop a trip generation model using SPSS. Then we will develop a trip attraction model as well using SPSS. And finally, I will show you a multiple linear regression using Python. So, in the first model, we are in the trip generation model. Here what we are trying to predict is the total number of walk trips generated or total trips generated from a particular zone. So, these are the potential dependent variables that we are considering, and the potential independent variables you can see male population, female population, number of households, number of business employments, commercial employments and other types of employments, then the different areas of different land uses, then area for business activities, area for religious use, the transit station distance, and then area under different commercial activities, religious use and so on, different area, and then built up area, and all the that means the floor area of different land uses are also considered. So, these are the different variables that we have got. This is similar to the one the regression model that we discussed earlier. So, in what we need to do is we need to go to SPSS, and there we need to go to the menu option, and in SPSS we go to first menu option is analyze, and then within regression we have got linear regression, and finally we once we do that, then automatically we get this box where we need to add the different variables, that means our dependent variable as well as the independent variables, and also we need to choose the method, that is over here we can default method is enter, that means all variables should be included in the model, and then we can also choose stepwise method, like variables which only explain a significant amount of additional variable is additional variance is only added. So, we choose that one. So, this is the small video of the analysis. So, we are choosing the after choosing the dependent variable, we choose the different statistics that we need to see, collinearity, then model fit, R square, Durbin-Watson, and then we can also plot the different normal, we can do normal probability plots to check the normal, if the data is normal or not. And then we can also put on the other statistics, we check the F statistics, then also we can finally we can choose the method, and we kept it at enter, and then we run and we get the results. And over here you get different kinds of estimates. For example, we start with the descriptive statistics, then the correlations, and then we also you can see the different the plot, and then this is the plot where we plot the residuals against the dependent variable. So, here we can check for the heteroskedasticity, if it is or homoskedasticity, that could be checked. Here we can check the PP plot or the QQ plot. So, this ones could be also, this is the PP plot that has been checked. So, the dependent variable that we have taken eventually is the total trips generated, and the independent variables that has been chosen are male population, business employment, distance to transit station, area under commercial use, and area of institutional use. So, total trips generated depends on male population, because the total number of probably total population, if we could have taken the age group wise, probably it would have given better results, but over here the male population seems to be more appropriate. And business employment, total number of business employment actually determines that now how many number of walk trips, non-home based trips would be generated. Then distance to transit station, that also plays a role. Area under commercial use, that also is because many people go from office to a retail area just to eat or to just shop in the surrounding area. So, those probably is also playing a role. Area of institutional use also could be shown to generate certain number of trips. So, we see that the model is F test shows that the model is significant and it is better than the model without any independent variables. That is being shown over here, and that is what the F test implies. And we see that the adjusted R square value is around 0.774. This is linear regression, explains around 77.4% of the variance in the data, and that we see in this particular table. So, R square is 7, this is around 749, 7 adjusted R square is 0.744, and then Durbin-Watson statistics is also given, and so on. And the total predictors are, we have the constant, then commercial employees, then transit station distance, institute area under institutional use, population, male and business employees. So, these are the different parameters, these are the parameters that are included in the model. So, this is the final coefficient table. Here we can see that these are the constant and the different variables that we have included in the model, and these are the beta coefficient, and we can see these beta coefficients are significant. All the values that has been adopted are significant. All of this has got positive signs except for transit station distance, which has got a negative sign. So, t-test is used to we also have got t-test, and this is also significant. This is used to check the significance of individual regression coefficients in the multiple linear regression model, unlike the F-test, which checks the overall consistency of the equation or the entire model. And then constant represents the number of trips generated in case all the variables are 0. So, we can see it is a pretty big number over here, and then 1 unit increase in male population, we see around 5.36 additional trips generated, and then sorry, it should be 4.36, not 5. And then similarly, increase in institutional area, commercial area and number of business employment leads to increase in number of trips generated. And finally, increase in transit station distance from the residence reduces the total number of trips generated. That is understandable. That means, the far away the transit station is, the chances of number of trips generated is also less. So, this also theoretically matches with the basic the findings also matches with the theoretical underpinnings of the model, and that means all the signs are as it should be. So, that is also a final check that we need to do, that all the signs are proper or not, and then we can say this is a valid model. So, then we discuss the trip attraction model, and this here the total potential dependent variables considered are total walk trips that are attracted or total trips that are attracted, and the total independent variables, as we have discussed earlier, these are the total population, male, female in the particular zone, number of households, number of different employments of different categories, then area of different land uses, area, then distance from transit station is still there, area under different commercial activities and so on, and then built up area, area of roads, built up area of different kinds of buildings, all these things are included. Now, either we can use built up area, that means which is an indicator of total floor space, and employment like like different kinds of employment, that is again a function, that means we can either this two could be very correlated, total number of either employment or area or even land use. Now, for some things like business or commercial, we may find that employment is a better indicator for commercial employment, where instead of a commercial land use or a commercial total floor area. So, we need to understand for which land use which one is better. So, in that way we can take a combination of all these variables as well. So, over here we found that the dependent variable is total trips attracted, and independent variables that we have used are business employment, other forms of employment, area under institutional use, floor area of commercial activities, floor area of residential use, area of vacant plots and male population. So, these are the total variables which have influenced the total number of trip attracted in a particular area. Now, there because we have taken business employment, then business use is actually it should be avoided, And then because we have got area of vacant plots, that means that is in an area if there is lot of empty space, that also has been considered by the model. Now, the F test value, as we can see over here, we can see it is significant. So, that means the model is better that means the model with the variables is better than the model without the independent variables, and we get a R square value of 0.858, which is pretty good value. Anything better than 0.75 is better for regression, but again a lot of people give different opinions. And then we see that these are the variables which are included in the model, and then we see that this is the model, the constant value is not significant, and then floor area residence is also this value is having a significance of 0.005. So, these are the two issues, and we see that the intercept constant is statistically insignificant, not different from 0, implies that when all the independent variables are 0, there will be no trips attracted. Well, this is an assumption, that is, this is what we are stating. That means that we can assume this, but actually it is showing something negative value. But we can say that because it is showing negative value, which is not possible, we can assume that when all variables are 0, then the model also is 0. That means this has got no significance, this constant value should be ignored. And then VIF is a measure of collinearity among independent variables. Floor area of residences has high collinearity with male population, considering trip attraction. So, that means even though the significance value is 0.005, because it is highly collinear, there is multicollinearity with other variables like floor area of residences. That is why it is with male population. That is why it is it should be ignored, and it should be removed from the model. And finally, all independent variables have positive regression coefficients as expected, except for AR-V plot, which is negative. Now, why it is negative? Because empty floor plot area actually indicates that there is lesser number of trips to be attracted, which is justified, because vacant land actually means that the total trip attracted to this zone will be less than it should have been if it would have been filled. So, that is why this one has got a negative sign, this AR-V plot. So, this is how we can do regression with using SPSS, and we can also do the final plot where we have plotted the residuals against the dependent variable, and we see that there is no trend or pattern visible, and we can also say that this implies that the model fits properly with this particular data. So, this is the video of this particular regression. We have chosen linear regression, then we are going to choose the different variables. First, we choose the dependent variable, which is trip attracted, as you can see over here. Then we are choosing the different independent variables, business employee, other employees, and so on. This is you can include them, but you have to understand we haven't got this variable in the first run. We have done many runs of the model to find out which actually gives us the best possible final results, and accordingly we have chosen the final variables, and we have finalized these particular variables. And this is where we are getting the results, the statistics correlation, there we can check the correlations, then the model summary, and finally where we get the adjusted R square values, and we get finally we get the coefficients. But we, as I was explaining earlier, we cannot take floor area residential because we had got high correlation with population of male population. So, this is how we can do trip attraction, develop trip attraction model using SPSS software. So, people who will not have the software or who wants to experiment with Python as well. So, we can also develop multiple linear regressions with Python, and we have already described how to download Python, how to install it, and what are the different libraries that are in use. We have also done a little bit of explanation of the different syntax that is being used. So, the syntax that we have to use for our developing these logistic models as well as regression model is very simple. So, anybody can follow that. So, first we start with importing the packages. Packages are the functions or group of functions or which are already written or present in the system or present in Python, which we can call and we can use it for our own purpose. And these packages are packages of this function. They are packaged in a way so that we can conveniently group them and we can access them as well. So, pandas package needs to be imported and linear regression module needs to be imported as well. And we use the sklearn package where we have the linear model, and we need to include the CSV file. This is the data file. We need to read that, and once we have read that, we have to put it in the data frame. So, this is the data frame. We have filled this particular data file, and then finally we have to extract the dependent and independent variables from the data set for both generation and attraction. So, we are developing both the models simultaneously, the production generation model as well as the attraction model. So, over here we have to first state that these are the columns which needs to be considered as independent variables, and this is the column which is the dependent variable, and these are the independent variables, and same we do it for attraction, and we save them in a variable. This is xgen and x attraction. So, we define these variables, and then so these arrays are there, and then we call the linear regression model. We fit the linear regression model, and we have called this linear regression function, and then we have fitted that. We have put xgen and ygen. So, these are the two variables where we have stored the array of this explanatory variables as well as the dependent variable, and then we estimate the coefficient, and we also estimate the intercept and the other parameters as well. So, we do it for the generation model as well as for the attraction model, and then we print the intercepts and all the other results. And so, we have done that over here, and we have also printed the different statistics over here, and these are the results you can see. So, trip generation intercept is printed, and then we have to print all the other columns, and then we also have printed the total R square value and so on. So, we get the results over here. So, all the variables you can see, these are the variables, and in this each variable and their coefficients are also listed. And over here for trip attraction, the same has been done. All the variables and their coefficient is also listed. And finally, we see that this is the result. So, in SPSS, these were our estimates, and in Python, using this scikit-learn function, this particular package, we have got this particular estimate. So, this more or less matches, like intercept was almost same. This is 0.435, this is 0.434, 2.76, 2.76, more or less exactly same results we are getting either using SPSS or using Python. So, same happens for the trip both for the trip generation as well as the trip attraction model. And here we can see that the intercept is a little bit changed, and the male population is there, and the reason it is changed is because of that we saw that two of the variables, male population and this commercial, one of the variables was correlated. That is why we had some difference. So, we see the R square values are more or less same. Mostly it is showing similar result. So, what we can conclude is that means it is very easy to write this kind of code in Python, because this kind of code is already available, and you can also just understand the model building process remains same. Only thing is, instead of typing in the code, we are selecting typing in the variables, we are selecting these variables from a list of variables in case of SPSS, and which we have to write a little bit more in case of Python. But if you use Python, then obviously you do not need to buy the software, which is relatively expensive and compared to other softwares available in the market. And this is this is how we can do multiple linear regression. So these are the references you can use, and we can conclude by saying multiple linear regression is the most common form of linear regression analysis, and whilst available software can help us to develop multiple linear regression, explaining the relationship between dependent continuous variables and two or more independent variables easily and quickly, care should be taken to consider the theoretical background and the logically obvious. That means, we should not even if softwares help us to estimate the models very fast, but we should be very careful that the theoretical background matches. That means, our a priori knowledge regarding this kind of model is not violated, and at the same time it should be logical, the explanatory variables should be logically obvious. So this is what should be considered while developing any model. Thank you.